So have a good day. My name is Jun. I'll start to talk about my presentation. As you can see on the screen, my topic today is identification of anthocyanin in black rice by using high-performance liquid chromatography, and this method is abbreviated as HPLC. So here is the outline. This presentation is structured as follows: introduction, methods, results and discussion, conclusion, and final is references. First of all, let's start with introduction. I'd like to give you an overview of rice. There are various types of rice, such as white and colored rice variety, that are grown across the globe. As you know, rice is considered as one of the major food sources of the world due to its nutritional components, such as carbohydrate, fiber, and protein. However, the rice variety, which contain color pigments as red, black, and brown, have an increasing interest from consumers in this day and age, owing to numerous health benefits on human life. And in this presentation, I'll focus on black rice. This slide will give you a general understanding about black rice. Firstly, black rice is a type of rice species or without sativa L that is glutinous and has a high content of nutrients. Besides, it's mainly cultivated in China and other Asian countries, and also known as forbidden rice and king's rice. Especially, black rice is a whole grain, super nutritious type of rice that is high in fiber, proteins, minerals compared to brown and white rice. So maybe some people will have a question about where the special black rice of this rice come from. And the answer is anthocyanin, which are a type of flavonoid and perform as antioxidants in the body. Furthermore, black rice is linked with health benefits such as avoiding heart attacks and stroke, improving digestive system, as black rice is loaded with dietary fiber. These days, there is a variety of methods to determine the total content of anthocyanin in food materials. However, most analytical methods haven't had high accuracy. Therefore, the objective of this study is to investigate the anthocyanin content in black rice by using a prevalent method, HPLC. Now let's consider method part. Reparative HPLC is used for extraction, isolation, identification, separation, and quantification of anthocyanin. Reparative columns is known as isolating compounds from natural extracts. Reparative HPLC columns are large in comparison to analytical columns, so larger particle size permits higher flow rate in columns. As you can see here, the flow chart indicates the preparation of anthocyanin pigments from black rice. Firstly, raw rice grain, around 50 grams, were defatted with 400 ml of anthocyanin and dried. Then anthocyanin pigments were extracted twice with 500 ml of 0.5% TFA in 95% ethanol overnight and filtered. After that, the root pigment solution was loaded onto a column, which was washed stepwise with flash distilled water, methanol to remove sugars, amino acids, and polymerized jet brown pigments. Next, the bright purple-colored anthocyanin pigments were eluted with 0.1% TFA in methanol with a ratio of 70/30. Finally, these partially purified aqueous anthocyanin pigments were further isolated, separated by repetitive HPLC in order to obtain cyanin-3-glucoside and pyridine-3-glucoside. Let's move on to results and discussion. Partially purified anthocyanin pigments were finally separated by repetitive reverse phase HPLC, and the HPLC condition described in this experiment allowed good separation of all anthocyanins as shown in this figure. This figure illustrates about high-performance liquid chromatogram of anthocyanins extracted from black rice, including 2 peaks, cyanin-3-glucoside and pyridine-3-glucoside. This is basic structure of anthocyanin, and here is specific structures of 2 anthocyanin, cyanin-3-glucoside and pyridine-3-glucoside. Moreover, cyanin-3-glucoside, which is abundant in pigmented rice, has been known to exert strong antioxidant activity due to 2 hydrogen group on the B ring. Let's move on and look at the table of retention time (TR) of anthocyanins, the studied and relationship between peak area anthocyanin content by HPLC. There are 2 major peaks, number 1 and number 2, which eluted near 11.34 and 12.05 minutes respectively, were separated and analyzed. An HPLC condition using a suitable column and a linear gradient was selected for separation and quantitative regression equation for C3G and P3G. The second table depicts anthocyanin contents in black rice investigated. According to this table, you can see the total content of anthocyanin in the black rice is 266 mg per 100 gram rice grain, while the major anthocyanins of black rice were identified as cyanin-3-glucoside and pyridine-3-glucoside. And my next point is conclusion. Through previous part, we can see anthocyanins are very reactive compounds, easily degraded or contains to polymeric pigments. Therefore, a rapid and efficient method is necessary to isolate, purify, and identify anthocyanin pigments in investigated products. And HPLCs in this experiment is considered as a suitable method to determine and analyze specific chemical composition in anthocyanin pigment inside the black rice with high accuracy. To sum up, cyanin-3-glucosides and pyridine-3-glucoside are the main anthocyanins in black rice, but C3G is the majority over P3G. Finally is references for my presentation. So this is the end of my presentation. Thank you for listening and have a nice day.